Hi and welcome. I'm trying to learn biochemistry today, triglycerides, and after we've done that, we're gonna do shoulder impingement training. And if you participate in a shoulder impingement training, then it's at your own risk. Triglycerides. And we're talking a bit about internal anatomy. I think that's right. Triglycerides. The most plentiful lipids in your body, on a human body, and in your diet or the diet which humans are eating, are the triglycerides. Okay, 1/5 of a human body is lipids, and that are fats, different types of fats, that was in the previous part. And the ones which constitute the most amount of it, the most plentiful one, are the triglycerides. Is it maybe pronounced like triglycerides? I'm saying with triglycerides. At room temperature, triglycerides may be either solid, fats, or liquids, oils. And they are the body's most highly concentrated form of chemical energy. Okay. At normal room temperature, at around 20 degrees or whatever, Celsius, where the triglycerides are either solid in the form of fats or they are in the form of oils, liquid. And they are the most concentrated storage of chemical energy for the human body. Triglycerides provide more than twice as much energy per gram as either carbohydrates or proteins. This is interesting. Okay, triglycerides have twice as much energy as carbohydrates or proteins. The common human body's capacity to store triglycerides in adipose, which is fat, tissue is for all practical purposes unlimited. I don't get to understand the sense. For all practical purposes. Whatever. It is unlimited. The amount of fat that a human body can store in the form of adipose tissue is unlimited. I'm wondering, because I was just thinking about, is that a good thing or a bad thing? I don't know. And now I want to express this not just as a joke, but as a serious question. Is that a good or a bad thing? Now, it would be a problem if a human body could not store unlimited and would get toxicated by it. But if a human body would pass it out, I don't know, serious question, is it a good or bad thing that the storage capacity is unlimited? Now, excess dietary carbohydrates, proteins, fats and oils all have the same fate. They are deposited in adipose tissue as triglycerides. Okay, if people eat more carbohydrates, proteins, fats and oils as they need, they are stored as in the form of triglycerides in adipose tissue. A triglyceride consists of two types of building blocks. Okay, it consists out of two types. A single glycerol molecule and free fatty acid molecules. Triglycerides, we're having three, that means free, we have free fatty, and glyceride sounds like glycerol. Okay, triglycerides are free fat, free fat acid, and a single glycerol. Okay, we're having a triple pack of fat and a single individual solitary glycerol. And they are together triglycerol. And they are the ones which are stored if people eat fat, oils, carbohydrates, and proteins as adipose tissue. A free carbon glycerol molecule forms the backbone of a triglyceride. A free carbon glycerol molecule forms the backbone of a triglyceride. Now consisted out of a single glycerol and a triple fatty and a backbone free carbon, whatever, free carbon glycerol molecule forms the backbone of a triglyceride. That's it on what it does. Free fatty acids are attached by dehydration synthesis reaction, one to each carbon of a glycerol backbone. So I understand it now. There is one glycerol and it is the backbone and free fatty acids. Okay, these free fatty acids are into the shelves of that thing, I don't know what it's called, into the shelves sorted of it by a dehydration synthesis reaction. One to each carbon of glycerol backbone. Okay. The chemical bond formed where each water molecule is removed is called an ester linkage. Okay, it is dehydrated, so water has been put away. Water is being put away. It is dehydrated and the water is put away, and that thing that is removed, now the bond itself that is removed is called ester linkage. And the removal of water helps to sort the free fatty acids into the backbone shelf thing of a free carbon glycerol. The reverse reaction, hydrolysis, I'm starting to get with the word hydrolysis and so on, makes sense. What is the translation to English of dialysis? Okay, hydrolysis breaks down a single molecule of a triglyceride into free fatty acids and a glycerol. Okay. So the dehydration. Okay, the dehydration makes it able to sort our free fatty acids into that backbone shelf thing, glycerol, the free carbon thing, the free shelves. And the water is removed by it. And the hydrolysis breaks down a single molecule of a triglyceride into free fatty acids and glycerol. I'm not able to explain it now. It somehow breaks it up and no water is put again or whatever, and now it becomes breaking up. We're having our shelf, our backbone, our glycerol, our free carbon glycerol, and our free fatty acids. In later chapters, we will, so that book, will refer to saturated, is with the meaning of saturated and unsaturated. As you know. In later chapters, we will refer to saturated, monounsaturated, and polyunsaturated fats. Saturated fats are triglycerides that contain only single covalent bonds between fatty acid carbon atoms. Okay? They do not contain any double bonds between fatty acid carbon atoms, and thus each carbon atom is saturated with hydrogen atoms. See, for example, palmitic acid and stearic acid. They have just one connection. The saturated fats are not are okay with being just together with a shelf with just one thing in the middle, so that it doesn't break down. Triglycerides with many saturated fatty acids tend to be solid at room temperature. Very not many. The other thing was that were saturated. The one with one bond, one covalent bond or whatever. Solid at room temperature and occur mostly in animal tissue. Okay, most animals, maybe we include humans here, I don't know, have fatty acids sorted into that shelf, and the fatty acids themselves are bound with just one covalent bond to the other fatty acid. The one in the middle is bound to the top and to the bottom. Monounsaturated fats contain fatty acids with one double covalent bond between two fatty acid carbon atoms, and thus they are not completely saturated with hydrogen atoms. Is it the same type of connection when it's just necessary to have two hydrogen things? Whatever. They are not completely saturated with hydrogen atoms. See, for example, oleic acid in figure 2.17c. Olive oil and peanut oil are rich in triglycerides with monounsaturated fatty acids. Well, I couldn't follow completely, but saturated, monounsaturated has something to do with how many bonds they have to the other fatty acids, all in their triglycerides. So if they're having one connection to the other fatty acids, or a double. No, why does it now have something to do with? Thus, they are not completely saturated with hydrogen atoms. Is it no problem to break them up? The hydrolysis or hydrolysis? Whatever, we can follow, we can continue. We understand that there are free fatty acids sorted into their backbone, into the free carbon glycerol thing, and if they are separated, they are connected with just one covalent bond to the other one, and hydrogen can, through hydrolysis, break them off again and make them usable. And monounsaturated have a double bond to the other three. We can continue and understand it later. That means, if you were here for biochemistry, you can go directly to the next part of biochemistry. If you're staying and participate in the short impingement training, then it's better to risk. We're having a good and still stance, and we do shoulder circuits. We're going back with shoulders, front and down, and again back, front and down. Another time. And backwards. Front, up, back, and down. Again in front, back, and down. And now long arms with strong fists. Go as far back as you can with the shoulders. High up, front, and down. Again, back, up, front, and down. And the other way around. High up, back, down, front, up, and down. Next exercise. We go having the legs wide apart, go a bit into the knees, hinge forward with a straight back, let the arms hang, and pinch the scapulars together with that. Make fists, lift the arms up and still pinch the scapulars together. Arms down, shoulders down, and another round, pinch the scapulars together. Make fists, lift the arms up and still pinch the scapulars together. Arms down, shoulders down. Now something similar. The sheet jump up into the knees, hinge forward with a round back this time, arms hanging, make fists, turn the arms to the inside, lift the arms up and bring them together. Straighten up, bring the shoulders down and together. Now bring the arms higher. Together, shoulders down and together. And release, and another round. Go a bit down into the knees, hinge forward with a round back, let the arms hang, make fists, turn the arms to the inside, lift the arms high up, bring them together, straighten up, bring the shoulders down and together. And lift the arms high up and bring them together for shoulders down and together. And release. And now, press the arms up and down. If this or any other exercise causes pain, then don't do it. Arms to the side and the front. And now we will lift out long arms with strong fists, shoulders down and together. Turn the arms to the inside. Arms to the outside, shoulders down and together. Arms to the inside, shoulders down, together. Arms to the outside, shoulders down, together. Release. Arms up to the side, a bit in front, and the arms in front, shoulders down, and together. Arms back, shoulders up, and front. Arms in front, shoulders down, and together. Arms back, shoulders up, and front. And release. Now lift the arms up for shrug, and shrug the shoulders up, and let it all down again. Another time, the arms up. One more time, arms up. Shoulders up, and all down. And replace the curl arms together, down at the side. And the next exercise is sun dive. You can use a sock or something else, have the long arm at the outside, let it fall down, and try to catch it again. And on the other side. And we're stretching the elephant trunk. Bring one arm in front, shoulders back, and down. Pull the arm in and have flat fingers. Try to relax the arm, go it back with the shoulder, turn the palm up to the sky. And the arm in front. Shoulder back and down, pull the arm and have flat fingers, try to relax the arm, go it back with the shoulder, turn the palm up to the sky. And release. that was the short impingement training. I thank you very much and until next time.